Hello, welcome to another session of the Chem Lab World Chemistry Lecture. Today we're going to be looking at mass and volume relationship. Now, if you watched our last video, we actually looked at a particular part of mass and volume relationships that has to do with what the number of moles. Today we're going to be looking at another part because if you check the last video, you would discover that we talked about amounts being equal to what? Reacting mass over what? Molar mass. Now, amount equal to reacting mass over molar mass, and the amount is concerned with the number of what? Particles, or the number of what? Moles. And in the last session, we actually gave a question that has to do with looking for the number of moles, and we actually solved it and got the number of moles to be 0.25 what? Mole of calcium chloride being obtained. Now, today we're going to be looking at how can we find the reacting mass of the reactant taking part in the reaction to give us what? The product. Now, before us here is a question which says, what mass of lead 2 triisonitrate 5 PbNO3 would be required to yield 9 gram of lead 2 chloride PbCl2 on the addition of excess sodium chloride solution NaCl? Now, here they're asking us for the what? The reacting mass of which compound? Lead 2 triisonitrate 5. So they're asking us for the reacting mass of lead 2 triisonitrate 5. That's what we are asked to look for. Now they gave us the reacting mass of what? Lead 2 chloride. Now, like I said before, the first thing you do before you solve questions that pertains to this nature is to write out the equation of reaction. So let's write out the equation of reaction for this particular question. Equation of reaction. Now, in the equation of reaction, we have the reactant side and we have the what? Product side. The reactant side is on the left hand side, the product side is on the what? Right hand side. So first of all, what are the reactants according to this question? They said, what mass of lead 2 triisonitrate 5 would be required? So automatically they're asking us, how much of lead 2 triisonitrate 5 would we need to what? React. So it means that lead 2 triisonitrate 5 is a reactant. So we have PbNO3 plus, to yield 9 gram of what? Lead 2 chloride. So PbCl2 is a product. Now, on the addition of excess sodium chloride. So when they add excess sodium chloride to what? Lead 2 triisonitrate 5, they got lead 2 chloride. So it means that the sodium chloride will be what here? NaCl. And it produces what? Lead 2 chloride. That is PbCl2. Now, of course, if you watch the last video, we said that this equation is not complete yet, according to the last equation of reaction that we looked at. In this equation, you see that Pb is here, Pb is here, Cl is here, Cl is here, but NO3 is not here, Na is not here. So we need to complete and balance the what? Equation. First of all, Cl2. We have 2 atoms of what? Chlorine on this side. But on this side, we have only 1. So we'll simply put 2 here. Now, automatically, we have represented the statement that says excess sodium chloride solution, NaCl. So by putting 2 here, we have made it what? Excess. So this part now, we have what? Balanced this side. Now let's look at this other side. That is all the atoms represented there, we have represented. Now let's look at this other side. We still have to represent this part. So now, Pb is Pb, only 1. Cl2 is Cl2. Now we have what? NO3 and we have Na. So plus NaNO3. Remember, this one is plus. Remember, we have 2 Na plus and we have NO3 minus. Is that clear? So NaNO3. Now, which other one is remaining for us to represent? I think that's all. We have represented Pp, Cl, NO3, Na. But now look at this. This 2 here is telling us that NO3 appear twice. So 2 atoms of this radical. Okay? And then this 2 is saying Na appear what? Twice. So 2 atoms of what? Sodium. So what do? We need to balance it up. So to do that, we just simply put what? 2 here. Putting 2 here tells us that we have 2 atoms of sodium and we have 2 atoms of what? NO3. This 2 is affecting this, is affecting what? This. With this, we have balanced the equation. I don't think there's any other thing missing anymore. So now, let's look at the number of mole. For this one, we said number of mole is the numerical coefficient of the word compound. So here we have an invisible one. So 1. Here, the number of mole is 2. So 2. Here, the number of mole is 1. So 1. And here, the number of mole is what? 2. So 2. Now, in this case, we are not concerned with the number of moles. What we're actually concerned with is what? The mass. So our focus will be on the what? Mass. So first of all, we'll look at which compound should we pay attention to. I said, what mass of lead 2 triisonitrate 5? What mass of this? PbNO3. So our focus is on this. Would be required to yield 9 grams of lead 2 chloride and what? PbCl2. So our focus is on this and this. Now, since they're asking us for the reacting mass of this, our focus will be on the what? Mass. Now, we'll first of all move from the known to the unknown. And then, before we can what? Solve it. So, what is the known in this case? First of all, the molar mass. Now, they have given us the molar mass of lead, molar mass of nitrogen, molar mass of oxygen, molar mass of sodium, molar mass of what? Chlorine. So, we need to calculate the molar mass of what? Lead 2 triisonitrate what? 5. Now, so Pb NO3 2. So the molar mass is equal to Pb is 207 plus, we have 2 here, this 2. Then N is what? 14 plus O is 16 for what we have here, and they have 3 of O, so times what? 3. Now this 2 here, the reason why it's here is because of this 2 that is here. Remember, we said that this 2 is telling us that NO3 appear what? Twice. That's why we have the 2 out here, and we're using it to multiply everything that is inside the what? Bracket. So we have 207 plus 2. Now 14 plus 16 times 3 is what? 48. Then we have, still on this, PbNO3 2. We have 207 plus 2. Now 14 plus 48, that will give us what? 14 plus 48, that will give us what? That will give us 62. So we have 62, 207 plus 2 times 62 will give us 4, will give us 124. So the answer here is what? 331 gram. That's the molar mass of what? Lead 2 triisonitrate what? 5. That's the molar mass. Now we have gotten the molar mass. Then let's go on to look for the what? Molar mass of PbCl2. Remember, our focus is on what? This and what? This. So PbCl2. Lead is 207 plus chlorine 35 35.5, and we have 2 here, so it's 2 35.5. So we have 207 plus 2 times what's inside the bracket is what? That'll give us what? That's 71. And so we have 278 what? Gram. So the molar mass of lead 2 triazonotrate 5 is 331. So let's see. We have this PbNO3 2 and then PbCl2. You understand why I wrote it this way? PbNO3 2 is on the reactant side, while it produces what? PbCl2. And then molar mass of this is what? 331 gram equal to what? 278 gram. Now, that's the molar mass. Remember, they're asking us for the reacting mass of lead, this one. Now, we don't know the reacting mass, so let's say it's X equal to, what's the reacting mass of PbCl2? 9 gram. So we have what? 9 gram. Now, from here, what we do next is to do cross multiplication, because we are looking for X. Like this, like this. So we have what? 278 X equal to 9 gram times what? 331 gram. So we have 278 X equal to, so we say 9 times, my calculator is wonderful. It has fallen several times. So we say 9 times 331. We have 2979. Divide both sides by what? 278. So X is equal to, divide by 278. Our answer is 10.7 gram. So therefore, 10.7 gram of what? PbNO3 is what? Required. So this is our final answer for this particular question. So if you take notes, you would notice that for looking for the reacting mass, the way in which we calculate it is quite different from the way in which we calculate for looking for the number of moles or the amount of what? Particles. Well, if you enjoyed this lecture, I ask that you click on the subscribe button and then subscribe to our channel so that you can always get notifications on our next video. Do have a nice day. Thank you very much.